continuing from the last video, our goal right now is to take the data that the user has typed in. And again, if you did not follow all of that exact syntax, don't worry about it. We're going to take the data that the user typed in, and we're going to put it into the shelve. So our first task, as according to these two comments here on line 36 and line 37, we're going to put the data into a Python dictionary. And then we're going to put that dictionary inside the shelve. So we can do a few things. We know that all of our interesting information is stored in these four variables: the problem, the answer, the guess, and whether it was correct. So I'm going to go ahead and have those be the keys inside this dictionary. So I'm going to say problem, and I'm going to go ahead and put the actual variable there, because this is the variable into which we stored that information. Okay, so there's the problem. Next, we're actually just going to do these one by one. So these, again, here on lines 32 through 34, these are the critical pieces of information that we want to store. Another way of saying store is persist. So we want to persist this information. Okay, so here's the problem. This is the correct answer. Okay, the answer. And let's see what they guessed. It was the guess. Oops. And then finally, was it correct or not? So I'm actually just going to name this the same way as that variable. You know, it would be totally fair if all you want to do is store the problem and whether or not they are correct. That would be totally fine, because we could always figure out the answer ourselves based on what the problem was, and maybe you don't care what they guessed. Maybe you just care if they got it right or wrong. After all, this is multiplication. We just want to know if they got it right. But I'm going to go ahead and put these in for now, because who knows, maybe one day you'll do some data science or some analytics and maybe you'd like to know these. Are there common, one thing you could do with this piece of information, the guess, for example, you could find out if there's very common mistakes. Like, is there the same common mistake, for example? But in any case, you can get to that on your own. So now we have this dictionary problem data. I'll make it even a little bit bigger. So this is a dictionary which contains data for a specific problem, but what's missing? We don't have any metadata. We don't have information about who did this problem, when they did it. Again, that's something that we are going to add on in the future. But the only other thing that's missing is the label. And n is the thing we're going to use as a label, but I better use it before I increment it. See, so this line, which is currently line 47, there it's getting incremented as if we're ready for the next thing. So let me go ahead and take this comment and move it up, since we're going to do this up above now. Pardon me for that. I'm going to clean up the comments in just a minute. So now that we have this problem data stored all nicely, we need to put it into the shelve. And oh wait, how do we do that? Let's go back to the docs and let's check this out. So once we have the name of our shelve, it says to store data at a particular key, we just use the name of the shelve. Sorry, I can make this bigger so it's easier to see. Pardon me. Okay, great. So it looks like we just use the name of the shelve followed by the key that we want, and then we put the data inside. And that's exactly what we're going to do here. So the name of the shelve, as we defined up here, is called math shelve. So I'm going to go ahead and put this here, math shelve. What key shall this be stored under? Well, we decided that n is going to be our key. We're just going to store these problems one by one, and that should be equal to, or that should be assigned the value of, pardon me, should be assigned all the problem data. So we're going to store the info into the shelve, and friendly reminder, we're using the key that we're using is just what order did they see these problems in, and it's all for one user. Finally, we're going to increment the label, and this is the end of our loop right here. So in case you got lost, notice this is indented in from the side. That's still part of this big loop, this for loop. I'll put another comment up here. So n is the label. We could really call it n is the problem number, and it starts at 1, and we're also using it as the label for the data. So if this all worked, by the way, let's get rid of these comments. Prompt the user with a specific multiplication problem. I think we're going to go ahead and put them up in the right spot here. Oh, code cleanup. 30 seconds of code cleanup. Here it comes. Okay, ingest the user input, check whether the user is right, store the data in the database. You know what, actually I think it's more clear if we don't have those comments in. Okay. But we might want to do something else, right? We might want to see if our code works. So I'm going to go ahead and write another loop now. I'm going to say this is for debugging purposes. After the user answers the problems, display what's in the shell. Shelve. Okay, great. We're just going to write a very quick for loop here. So I'm going to say for whatever's inside there. So I don't know, piece of data for data in math_shelve dot keys. All right. Well, let's say this really is going to be n problem number. I'm going to make this very explicit. So for problem number in math_shelve.keys, why does this work? Math_shelve.keys is going to return an iterable of all the keys that exist inside this shelve. And then we're going to go through them one by one, and I'm going to print a problem was answered. Or let's say data is present for problem, and I'm going to use this trick again where I do dot format. I'm going to go ahead and put in, decided I'm tired of looking at this long variable. I might just call it P for now, because I want you to be able to see this all in one line. Okay. K. K is a little bit more clear, because it's a key. K is short for key. All right, so for K in math_shelve.keys, let's print data is present for problem this. Okay. Data found for problem blah blah blah. So if everything goes well, this should then tell us at the end of when our program runs, it should tell us what happens. Okay, the moment of truth. Let's go ahead and see if we can run this code and get it to work. It should ask me to do some problems, and I'm going to then guess. I'm just going to guess. I've decided that I'm going to guess 5. Okay, good. Let's see what we got here. Getting an error for using this as a key. Good. Real life strikes. So it looks like we might not be allowed to use it as a pure int. So let's go ahead and we're going to turn it into a string. Okay, let's see if that fixes our problem. Okay, so right now I've just decided I'm guessing 5 for all of these. We should see what happens here. And it said it found data. Okay, so I'm going to explain a few things in rapid succession. I'll go into them in depth the next time more. Actually, you know what? I think this would actually be a good place to pause. So see if you can explain what just happened. What was the error that I got? I can go ahead and show it to you again. Pause it and try to figure out why did it not like this line? And a hint, it gave us this error, attribute error, int object has no attribute in code. See if you can figure out what that means. This is actually, debugging is a really important skill that I sometimes take for granted. So see if you can pause the video and figure out what that means. We'll pick up from this next time.